Hi there, it's Cherylea from Anatomy for the People. In this video, I'm going to be talking about blood typing. So there are lots of different types of blood groups throughout the human population, but the most important one is the ABO system. And this is going to include the rhesus factor, specifically Rhesus-D. Okay, so what determines what type of blood you have? It is all about the surface proteins that you have on your red blood cells. So your red blood cells are also known as erythrocytes. So I'm going to just draw a table now and talk about what type of surface proteins we have on our red blood cells and how our immune system protects us against foreign blood groups entering into our cardiovascular system. Okay, so the ABO blood groups that we have are blood group A, blood group B, AB, and O. So what does this mean? So let's have a look at our red blood cells. So every cell has a cell surface. That's what encloses it and keeps all of its things inside. So these cell surface proteins, or antigens, are what determines what type of blood we have. So individuals with type A blood will have A surface antigens on their red blood cell. And I'm going to draw that as a little spike. So if we look on the surface of these red blood cells, someone with A type blood is going to have these A surface antigens on them. So this is the A surface antigen. Colour them in for continuity. Okay, so someone that has type B blood is not going to have these A type antigens. They're going to have their B antigens. And let's do them as these blue little circles. Obviously, they don't look like this in real life. They're more like, but this is a schematic diagram. So here we have our B. Okay, so then now people that have AB blood, they're going to have both of these antigens. So since I've got the blue in my hand already, we'll just do some B surface proteins on here and some A. Okay, so this individual has AB blood. And the individual that has O-type blood, they have neither of these surface antigens on them. Obviously, they have surface antigens because they have a cell surface, but not these particular ones when we're talking about the ABO blood typing. Okay, so this is what tells you what type of blood you have. So we're looking for these particular antigens or the lack of those antigens, and that will tell you what type of blood you have. So what our body does to protect us against foreign blood types from entering into our system is to create something called an antibody, which is going to protect us against antigens that don't belong in our body, so foreign antigens. So our red blood cells move around our body suspended in plasma, which is water, plasma proteins, hormones, antibodies, lots of things mixed in. So in our plasma, we have, as I mentioned, antibodies. So antibodies are protective proteins which are created by the immune system, specifically created by a cell called a plasma cell. So antibodies are released into the plasma, so released into the bloodstream where they can do a range of things. So they can attach to foreign organisms or foreign invaders and mark them for destruction. They can prevent certain foreign antigens or foreign cells from entering into the host cells or entering into your own cells, and lots of other things. But the antibodies involved in this ABO blood typing system will attach to foreign blood cells and cause them to agglutinate, causing them to clump together, which significantly disrupts their function. So this is a protective mechanism to ensure that blood that doesn't match with our own isn't popped into our system. However, we know that we are able to receive blood types that aren't our own. So I'm going to talk about how that's possible a little bit later. Okay, so let's talk about the antibodies that are in this system that prevent foreign blood from entering into our own. Let's have a look at an individual that has A-type blood. So someone that has A-type blood is actually going to have antibodies. So now Just so you don't get confused, that's my little legend over there. Just put a little dotted line. It's its own little thing. So in here, we're going to have the antibodies. So someone with A-type blood is going to have anti-B antibodies within their plasma. So anti-B means against B. So they're going to be shaped with little ends that are perfectly made for B surface antigens. So this is anti-B. So this means if someone with A-type blood received a blood transfusion with someone with B-type blood, the B-type cells that went in would then have all of these antibodies attaching to the cell surface and causing them to agglutinate, and then they would be destroyed. So this antibody here that floats around in someone that has type A blood is protecting this individual against any B surface proteins, so any red blood cells that carries that surface antigen, from entering into that circulation. So obviously you can see that we've got this circle shape here, which is made perfectly for those B surface antigens. So these two can exist in perfect harmony because we're not going to have them attaching there and destroying the host's cells. So this is what an individual with A-type blood has floating around in their plasma, protecting against foreign blood types. Then now if we have a look at someone with B-type blood, we don't want to have anti-B antibodies because that would destroy the cells. What we need is anti-A antibodies. And I'm doing this the same colour so you can see the match there. So we can see we've got the little spike there, and this would be your anti-A antibodies. So again, these exist in perfect harmony. There's no cross reaction there. And this is basically in place to prevent any red blood cells that contain the A surface antigen from entering into the bloodstream of this individual. So then someone that has type AB blood, it has neither anti-A or anti-B, because if it did, it would attack its own cells. So let's just do a big old cross. Please keep in mind that the individuals with AB blood, just because they don't have anti-A or anti-B doesn't mean that they don't have other antibodies. Okay, so now we move to someone that has O blood. So the O red blood cell doesn't have either A surface protein or B surface protein. So what's considered foreign to someone that has O-type blood would be anything that did have A surface protein and B surface protein. So this means we need to have anti-B floating around and anti-A. Because if A surface protein or B surface protein entered into someone that had O-type blood, that would be foreign, very foreign to someone with O blood. So now we know about the types of antibodies that float around in the plasma of these individuals, protecting them against foreign blood groups. And we now know the different surface antigens that are on the red blood cells of all of these blood groups. We know that we can actually receive blood that's not of our own. And so if we look at this table, that is quite confusing. How can we receive blood that is not of our own if our body has put mechanisms in place via these antibodies to protect us against foreign blood? And it's actually a very simple way we can get around this and kind of trick the body into thinking that cells that it's receiving are not foreign. So let's go to the person with AB blood. So someone with AB blood needs a massive transfusion. Let's say there's no AB blood on hand. What do? We know that we can actually give someone with AB blood, we can give them A blood, B blood, and O blood. But then you might be thinking, well, how is that possible? So someone with AB blood needs a massive transfusion. There's no AB blood on hand, however, there's lots of O blood. So you can give them O blood, but if you have a look at the antibodies floating around in the plasma of someone with O-type blood, it has both anti-A and anti-B. So if this is moved into the bloodstream as someone with AB blood, there is the concern that the antibodies that are in the O-type blood plasma will then attach to the surface proteins of the host's blood cells. But we know that we can give people with AB blood O blood. So how do we get around this? What we need to do is remove those antibodies. Because if you removed these antibodies and just gave someone with AB blood O blood cells, then they can go in and that's fine. And again, if you gave someone with AB blood, if you gave them B blood and moved that over here and removed these antibodies, then there's no antibodies within the AB plasma that's going to pose a risk to O-type cells, B-type cells, or even A-type cells. So we need to remove the plasma and therefore remove the antibodies so that we can actually move blood types to different blood groups. So how we do that is blood is spun at an incredibly fast rate in a machine called a centrifuge. And what that does, it spins blood really fast, and what happens is that in the tube, the heavy blood cells will move to the bottom of the tube, whereas the plasma will sit on the top. So if you spin down your blood, and I'll just draw it. So we've got our little flask here, a little test tube, and you've got your blood in it. Okay, and that's everything all mixed together. That's whole blood. Then you spin it, and then what you do get, is your heavy cells moving to the bottom. So this is after it goes in the centrifuge. So you have your red blood cells going to the bottom. Sitting on top of that layer, you'll have something called your buffy coat. And this is going to include your white blood cells and your platelets. And then above that will be your plasma. So if you can physically separate it like that, we know that the antibodies are sitting in the plasma. So if you remove the plasma, see you later, just pour it on the ground. Don't pour it on the ground. Someone could slip. Get rid of the plasma. Oh dear. Oh. Get rid of it all. And therefore you are just left with your red blood cells. So this is how we can receive blood types from other blood groups, that are not of our own. So AB can receive A, B, and O. So AB is actually known as the universal recipient. So it can take A, B, obviously AB, and O. Now, let's have a look at someone with A blood. What can they receive? So they can obviously receive A. That's easy. But if that's not on hand, can they receive B blood? Even if we remove the antibodies here, the anti-A, and put these ones in here, that's not going to work because the host's antibodies will still be produced. So when the B cells are put in, the host's antibodies are just going to make them agglutinate, and that's not going to work. So therefore, they can't receive B blood. And then the same goes for someone with A blood. They can't receive AB blood. Even, there's no antibodies in their plasma to worry about, but they still are going to have the B surface protein. So the host's antibodies, which you can't remove because they're constantly produced by the host, you can only remove antibodies from the blood sample. So they can't receive AB blood. O blood, can they receive it? Let's remove the antibodies. So the anti-B antibodies are not going to have any issue with that blood cell. So someone with A blood can receive A and O. Then someone with B-type blood obviously can receive B. And the same goes, they can't receive A because they've got anti-A floating around in their plasma, which would agglutinate the cells if they came in. So no A. Again, the same for AB. It's got A surface proteins on there, which the host's antibodies would attach to. Okay, but again, we can have O. So O's great. Love O. We can see O can be given to A, to B, and to AB. So O is known as the universal donor because it can be given to everyone. So now let's have a look at what O can receive. So O can receive O, obviously. but can O receive A blood? And the answer is no, because the A surface protein on these red blood cells, they will cross-react with the host's anti-A antibodies. So it can't receive A, and that same goes for B. It can't receive B because the host antibodies will just attack any B cells that would come in. And that's, again, the same for AB blood. So O can only receive O. But luckily, they are the most common in the population. So there is, I'd say, a little bit more of that in the blood bank. Okay, so that is the basics of the ABO blood typing system. However, you know that you don't just say, oh, I have A blood or I have B blood. You say, I have A positive or A negative blood. So what is this positive and negative thing about? So it's got to do with another surface protein, and it is the rhesus surface protein. So there are up to 40 different rhesus proteins, but the most common one is the Rhesus-D surface protein. It's called rhesus because it was first discovered in the blood of a rhesus monkey. So this just adds another layer of complexity when you are talking about blood transfusions. So let's just do a red blood cell down here. And let's say this person's blood group is AB positive. So what that means is we're going to have our A surface proteins, our B surface proteins as well. And then we're also going to have that Rhesus-D surface protein. And you may have heard of it just referred to as D, but it's Rhesus-D. So let's just do that as a little line. Okay, so then that's our Rhesus-D surface protein. Then if you had a look at the plasma of these individuals, since they have all of the surface proteins, they're not going to have any of these antibodies within their plasma. So it's going to be like this, and then that's the same for D, or anti-D. So you're not going to have that. Okay, so then if we had someone with, let's pop it down here. Let's say this individual has B negative blood. So we're going to have B surface proteins. Okay, so we can see that someone with B negative blood is going to have the B surface protein, but not the rhesus surface protein, the Rhesus-D. So that's negative. So to avoid me drawing it again, this plasma here is going to be the same because this is essentially B negative. So there's going to be anti-A floating around to prevent any A surface proteins from entering into that person's body. But there's not actually going to be anti-Rhesus-D or anti-D antibodies floating around in the system just yet. So the anti-D or anti-Rhesus-D antibodies, they will only be created if that individual has been exposed to Rhesus-D surface proteins. So that can happen in childbirth, that can happen in a mistake with blood transfusions. So now that we've added in this rhesus surface protein into the mix here, this is going to change this slightly. We're still going to be able to receive the same blood groups, but now we have to take into consideration the positive or negative signs, so the positive for Rhesus-D or negative for Rhesus-D. For the sake of time, I'm not going to draw up the entire table of compatibilities of all the different blood type groups, but if you're interested, you will find the table down in the comment section. I hope that you've learned something today, and thanks for joining me. See you next time.